All right, so today we're going to be looking at Unit 8, Notes number 7, and we're going to look at another method for solving systems of equations, and it's actually going to be our last method. So we've looked at graphing and we've looked at substitution, and so today our method is going to be elimination. So this is a method that you can use when maybe substitution is going to take too long or it's going to be a lot of initial steps. There's another method that you can use. So looking at this, just a quick reminder, when we're determining whether each point is a solution to the system, one thing that you can do is just plug in x and y to see if it is true for both equations. It has to be true for both. So remember, this is your x and your y, and so we can substitute that in. So the first one is just x plus y equals 5. Well, now it's going to be 4 plus 1 is equal to 5. Which 4 plus 1 does give me 5 is equal to 5. So we know that it works for the first one. So now we have to check for the second one, which is y equals 3x plus 1. So for that, we'll have instead of y, it'll be 1 equals 3. And instead of x, it'll be times 4. I think that was a plus 1. Yep, plus 1. And then we just have to simplify. So 1 is equal to 3 times 4 gives me 12. Plus 1 gives me 13. Well, those are not equal, therefore this is not a solution. Remember, it has to be true for both. Okay, so we're going to try option B, which is 2, 3. Remember, this is my x and my y. Plug it into the first one first. We'll have 2 plus 3 is equal to 5. Well, 2 plus 3 does in fact give me 5 is equal to 5, so it works for that one. So now we have to check to see if it works for the second one. So we'll have, instead of y, it'll be 3 is equal to 3 times, instead of an x, it'll be 2 plus 1. So we'll have 3 is equal to 3 times 2 gives me 6 plus 1 equals 7. So that's not true for that one either. Okay, so this one's also not a solution. But if it had been true for both, then this would have been a solution. It has to be true for both. So I gave you 2 non-solutions, but that's okay. All right, so now we're going to look at our actual method for today. And remember, for solving equations or solving systems, you can't just start plugging in every single point. That would take forever, and that would really be impossible because there are infinitely many points that could be solutions. So that's why we have these 3 options for you to work through. So looking at the first one, this says solve the system algebraically, and I've given you your steps over here. Step number 1 is a mystery step because we don't actually have to do the first step in this one. But our mystery step is all about getting a variable to cancel out. That's always going to be a goal with the first step, is how can I change these coefficients to make something cancel out? So getting a variable to cancel. And what I mean by that is if we look at this problem, notice that I've got 3y and negative 3y. When I add those together, they cancel out. So that's why I don't have to do the first step, because I'm already there. I'm already where something is going to cancel out. So our second step is add the equations together. Now, what do I actually mean by that? Wow, that writing was very messy. Sorry, guys. That's an A right there. So we're going to look at this problem, and we're going to turn it into a big addition problem. Okay, and we're just going to add down. So 4x plus 2x will give me 6x. 3y plus negative 3y cancels out. Those go away, which is good. We want the y's gone. Equals 16 plus 8 gives me 24. So now we have a super easy equation to solve, which is nice. So to get the x all by itself, we're going to divide out the 6. We'll have x is equal to 4. Which, if we look at this, that was our third step, was solve for x. Because the y's canceled out. Okay, so we added the equation together, which was good. The y's canceled, so then we solved for x. So now we have our x is equal to 4. So now all we have to do is plug this into one of the equations to find the y, which basically turns into what we were doing with substitution. So I'm going to take this 4. I'm just going to use the top one because I don't really want to mess with the negative. So instead of 4 times x, it becomes 4 times 4. Awesome. And then, what was the rest of it? Plus 3y is equal to 16. So now we're going to solve for the y. 4 times 4 gives me 16. Plus 3y is equal to 16. We're going to subtract out the 16. Those will cancel. So we'll have 3y is equal to 0, because 16 minus 16 gives me 0. 3 times y, to get rid of the 3, we have to divide the 3 out. So that'll go away, and I'll have y is equal to 0. So our point, or our solution, okay, is going to be one solution. At the point 4, 0. So if I were to graph both of these equations, they would intersect at the point 4, 0. So step number 4, what did we do in that step? Okay, well, we substituted, and then we solved again. Okay, and that time we solved for y. We got the y all by itself. All right, let's try and do the same thing with number 3. So we have solved the system algebraically. We have 2x plus 3y equals 15, and 3x plus 6y equals negative 9. But if I look at this, 2x and 3x don't cancel, and negative 3 and 6 also don't cancel. So this is where we have to use that mystery step. We have to figure out, what can I multiply one of these equations by to make them cancel? Well, if we look at this, these are already opposite signs, which is good. So we want to focus on those because they're already opposite signs. So that means they're a little bit closer to canceling out. Well, what could I multiply this negative 3 by to get to the 6? I could multiply it by 2, and then I'll have negative 6 and 6, which will cancel out. Okay, so we're going to do that over here. So I'm going to multiply everything by that 2. You have to multiply all the coefficients by the 2 in order for this to work. Okay, that's not an optional step. That's a requirement. So 2 times 2 will give me 4x. 2 times negative 3 gives me negative 6y. Equals 2 times 15 gives me 30. And I'm just going to bring the other equation over. So I had 3x plus 6y equals negative 9. So now if I look at these, now negative 6 and 6 will cancel each other out, which is good. I haven't really changed anything. I just multiplied. Okay, so now whenever I add those together, I'll be able to cancel it out. So what did we do in the first step? We multiplied the first equation by 2. So now we're going to add everything together. 4x plus 3x gives me 7x. Negative 6 and 6 cancel out, which is awesome. And then 30 minus 9 gives me 21. Or plus a negative 9 gives me 21. Divide out the 7s. And we'll have x is equal to 3. So now, okay, that was step 2 and 3, my bad. So add the equations together. And solve for x. Now, sometimes you're solving for y. Okay, it doesn't matter what you're solving for. All right, so now step 4, we're going to substitute that back in and solve again. So we're going to plug in that 3. I'm going to use the second one just because it's all positive, well, except for the negative 9, but that's a little bit easier to work with. So now I'll have 3 times, and 7x is a 3, plus 6y is equal to negative 9. And then I just have to simplify and solve. So 3 times 3 gives me 9, plus 6y is equal to negative 9. Subtract that 9 over. That'll cancel. I have 6y is equal to negative 9 minus 9 gives me negative 18. Divide out the 6. I'll have y is equal to negative 3. So now we have our point, and it's going to be one solution. That means they only intersect one time. at 3, -3. All right. Okay, let's flip over to the back page. So looking at number 4. It says solve the system 3x plus 5y equals 2 and 4x plus 3y equals -1 and find the value of 3y plus x. So we're actually going to solve this system and then plug those into our equation or our expression over here. Now looking at this, 3x and 4x, those aren't going to cancel. And 5y and 3y also aren't going to cancel. Notice also that I can't multiply any of those equations by just one thing to make them cancel. Okay? Because I can't multiply 3 by anything to get to 5. And I can't multiply 3 by anything to get to 4. It just doesn't work. So what I'm going to have to do is multiply both equations by something. Okay, so I'm just going to look at my first coefficients with the x's. I have 3 and 4. My goal is going to make those cancel out. So what I'm going to do is I'm going to multiply everything over here by a -4. And then everything over here by a +3. Notice I just took that coefficient, put it over here, that coefficient, put it over here. Because whenever I multiply those, they're going to make a number that will cancel out. And we're about to see that. So we're going to multiply everything on this one by -4. So I'll have -12x plus 5. Nope, not 5. -4 times 5 gives me -20. -20y. And then -4 times 2 gives me -8. And then on the second one, we're going to multiply everything over here by a +3. So 4 times 3 gives me 12x. Notice that those are going to cancel, which is what we wanted. 3y times 3 gives me plus 9y equals -1 times 3 gives me -3. So now this is where we get to turn this into one big addition problem, which is what we wanted. Awesome. So -12 plus 12 cancels out and goes away. -20 plus 9 gives me -11y is equal to -8 plus -3 gives me -11. We're going to divide out the -11s. And I'll have y is equal to -11 divided by -11 gives me 1. So notice we solved for y that time. See, it doesn't matter what you cancel out first, just as long as something cancels. So from here, we've got our y. Now we're going to plug this back in. You always want to plug back into one of your original equations. That, just in case you made a mistake somewhere, you want to plug back into an original. So we're going to plug that in. I'll have 4x plus 3 times, instead of a y, it's actually a 1 now, equals -1. And then we just got to simplify. So I'll have 4x. 3 times 1 gives me plus 3 equals -1. Subtract the 3 over. Those will cancel. And I'll have 4x equals -4. Not quite done though, so we need to divide out the 4. Now have x is equal to -1. So we have 1 and -1 for our solutions, or solution. So we're going to take those points, because we're not done yet, and we're going to plug them in up here. So we'll have 3, and instead of times y, it'll be 1, plus our x was actually a -1. And then we just got to simplify. 3 times 1 gives me 3, plus a -1. 3 plus -1 gives me 2. So my final answer is 2. Fun stuff. All right. So looking at the next one, number 5. We are almost done, guys. So it says solve the system 3x plus 8y equals 2 and 2x minus 7y equals -11. And find the value of 5y minus x. All right. So looking at these, the first thing I notice is that 8y and -7y are already opposite signs, so that's good because they're already one step closer to canceling out, which is what we want, okay? So that means I'm going to use those coefficients to multiply both equations by, because there's no way to get 2 to be a 3, and there's no way to get a -7 to be an 8, okay? So that means we have to multiply both equations. So I'm going to multiply everything over here by a 7 and everything over here by an 8. I don't need to worry about the negatives because they're already different signs, which is good. So when we do this, we have to multiply everything. So 7 times 3 becomes 21x. 7 times 8 becomes plus 56y is equal to 7 times 2 becomes 14. And then multiply everything over here. 2 times 8 becomes 16x. Oh, I forgot the 6 in there. I just wrote 5y. My bad. Negative 7 times 8 gives me minus 56y is equal to negative 11 times 8 gives me negative 88. Some kind of big numbers, but that's okay. That's why we got those handy dandy calculators, right? So we're going to turn this into a big addition problem. Those cancel, which is awesome. 21 plus 16 gives me 37x. And then 14 plus a negative 88 gives me a negative 74. We're going to divide out the 37x, or just the 37, my bad. And we'll have x is equal to negative 74 divided by 37 gives me negative 2. Which turns out quite nicely, thank goodness. So now it just turns into substitution. We're just going to plug that right back in. Okay, doesn't matter which equation you use either one. So we'll have 2, and instead of times x, it's times a negative 2. Minus 7y equals negative 11. 2 times negative 2 gives me negative 4. Minus 7y equals negative 11. The negative 4 needs to be moved to the other side, so we're going to add 4 over. Those will cancel, which is nice. So I'll have negative 7y is equal to negative 11 plus 4 gives me negative 7. Well, this is going to turn out nicely. Divide out the negative 7. We'll have y is equal to a positive 1. So now that we have all that, we need to take both of our coordinates, or pieces of our coordinates, and plug those in. So we'll have 5, instead of times y, becomes times 1, minus my x, which was a negative 2. 5 times 1 gives me 5. When I subtract a negative 2, I'm really adding the 2. And then 5 plus 2 gives me 7. All right. Remember, if you think I went a little fast, rewind, hit pause so you can get all that written down. Number 6 says Chuck's Chocolates has M&Ms that sell for $2 per ounce and pecans that sell for $3.50 per ounce. Chuck wants to make a 12-ounce mix of M&Ms and pecans to sell for $30. It's a lot of M&Ms and pecans. So that's what we're really looking at, though, is the ounces of M&Ms and pecans. So when we define our variables, we're going to let x equal the ounces of M&Ms. You can't write number of M&Ms because that's going to be a lot different than the ounces. We're going to let y equal the ounces of pecans. Well, that did not turn out right. Wow, you know what I mean. Just not wanting to let me write ounces. All right, so now we're going to set up our equations. So we know that the total ounces need to be a 12-ounce mixture. Okay, so we're the ounces of M&Ms and the ounces of pecans, so x plus y needs to add to 12. So those are our ounces, but we also have our money numbers. So we know that for every ounce of M&Ms, it's $2. So ounces, or all of my x's, have that 2 with it. So it's going to be 2x plus pecans are $3.50 per ounce. So plus 350 y. And we know that we want our total mixture to cost how much? To cost $30. So remember, like last time, if it's pounds, pounds, and pounds, it has to go money, money, money. You have to be able to say that for each of your labels. Okay, so just make sure you're lining those up correctly. So now we're going to use elimination to solve this. Okay, so I want to make something cancel out. The 2's, or this 2 right here, is going to be really easy to use because I can multiply everything up here by a -2 to make the x's cancel. So that's what I'm going to do. So I'm going to multiply everything up top by that -2. I'm just going to rewrite it below this other equation. So 2 times x becomes -2x. 2 times y becomes -2y. And 2 times 12 gives me -24. So now we're just going to add everything together. 2x plus a -2x cancels out, gives me nothing. That's perfect. 3.5 plus a -2 is going to give me 1.5y. And 30 minus 24 gives me 6. Divide out the 1.5. Okay, well, 6 divided by 1.5 is going to give me y is equal to 4. So that gives me my y, which we said was the ounces of pecans. So I'm going to need 4 ounces of pecans. Now I need to figure out how many M&Ms. So I'm going to plug that back into my original. Solve x plus, instead of a y, it becomes a 4 equals 12. Subtract the 4 over. And I'll have y is equal to 8. And I'll need 8 ounces of M&Ms. So we're going to write that out. Wow, rid of y. That should be an x. That's what happens when you go too fast, guys. So I need, or what, actually it's not me. Who is it? Chuck. Chuck needs 8 ounces of M&Ms and 4 ounces of pecans. All right. If you have any questions, please make sure you're emailing your algebra teacher. If not, now you can move on to that wonderful Google form that you've got. Remember, the Google Forms are graded on both completion and accuracy, so please make sure you're taking your time and trying all of those problems.